Hello everyone, welcome back to another Data Analytica video. And in today's session, we will explore how to handle missing data in PySpark. So I'll walk you through different techniques you can apply to manage missing values effectively. So let's get started. And here I am on Databricks Free Edition. And the first thing that I'm going to do is get the CSV file that we're going to use as a source file to do this whole missing data handling. So to do that, like in previous videos, what I'm going to do is I'm going to create a managed volume. And in order to do that, I'm just clicking on Add Data. And in Add Data, click on the Upload Files to a Volume. And here I'm going to create a new catalog called Data. And I'm going to create a new volume called CSV files, managed volume, and I'm going to create it. So it has been already created. And to this volume, I'm going to get the CSV file that we're going to use in this session. So I have a missing data 1000 CSV file which has 1000 rows. And I'll show you how the data looks and what kind of data we have later in our video. So let's click on upload, and it has been uploaded. So now let's close this, and what we're going to do is we're going to let me move to trash. I'm going to create it again. So PySpark handle missing values. So yes, let's start by setting up the PySpark, and how we are going to do it. Let's get those PySpark.sql. Let's import the PySpark Spark session, and then let's get from PySpark.sql.functions import mean, call, sum, coilies, when. So these are some of the functions that we're going to use, and then we will be using some visualization as well. So to use that visualization, I'm going to get matplotlib, as plt, and then pandas. To work with visualization, we need to convert our Spark data frame to pandas, and to do that in import pandas as pd, and then I'm also gonna get Seaborn for some visualizations. So let's click on run. Yeah, I missed a T. Great. So the next thing that we're going to do is initialize Spark session. Spark equal to Spark session builder dot app name. So I'm going to call this as handling missing data, and get or create. Sorry, miss Okay, Spark session app name. Super. So now we have initialized a Spark session. And the next thing that we're going to do is we need to load the data set that we are going to use. So in order to do that, so we have 1000 rows with missing values. So that's our data set. So file path is going to be volumes, workspace, data, CSV files, and then missing data 1000.csv. And next thing is we're going to create a new data frame by reading data from this file path and keeping its header true and info schema also true. Okay, so let's run this. Okay, great. So it returned the df that has been created with columns ID, name, age, and salary. So the next thing that we're going to do is let's look at like how that data looks like. And in order to do that, we will be just printing print data. Okay, so df.show 10 and let's run it. Okay, so here we have ID with integer values, name with string values, age is also numeric, and salary. And here you can see that in name column, we can see there are actually some missing values. For some rows, it's actually giving us null. But for others, for the first top 10 rows, we are not able to see any missing values. So the next thing that we're going to do is we'll see like how many values under each column are actually null, and let's see like the count of that. So in order to do that, first let's examine, maybe let me get a markdown, examine current data. Okay, so first thing that I'm going to do is create null indicator. So we need to actually check the null count by doing an indicator when it's null under each column. So how we are going to do that, we'll actually create this missing counts, which is actually df.select. So we will have a list expression, so which is called c dot is null dot cast of. So when it's null, we will check if it's null, then we will actually cast it to int value, which is when it's boolean, true will get to 1, and we will give it that column name, sorry, for c in df dot columns for each column. So we'll do this for each column, and after that we need to actually count the number of those one value, right? When it's null, then it gets converted to 1, and when it's non-null, then it becomes 0. So the next thing that we're going to do is we need to aggregate those ones to get the total count of missing values. So let's aggregate and keep original names. So how we are going to do that, we will actually work on this missing counts. And okay, missing counts dot group by. So we need to have we need to group by and we will have aggregate, and we'll do the aggregate on each column. So sum of C, and we will name. So why we are doing this alias here, because without that, usually it's possible that the column name, once we do the transposing, it will become like, let's say ID gets changed to sum of ID, name gets changed to sum of name. So in order to keep that value, the column name as it is, we're going to use the alias of C. And then for C in missing counts dot columns. So if you have used some kind of list comprehension insight like this, you might notice that this will throw an error if we don't put a star, this indicator, in the beginning, because when you actually use this indicator, it actually tells to unpack this whole thing, and each expression gets passed individually for each column. Otherwise, it will throw an error. So don't forget to put this this star sign when you have a list comprehension like this. Okay, and next thing that we're going to do is we'll actually convert this to pandas, and then we will have a transpose. So this is actually transpose we are doing, and then we will also reset its index. Okay, so now let's see what we have in our missing counts. So after transposing, when usually like those columns will actually come under index. So to rename that as column, so we will rename that index to column, and then we will give missing count. Okay. So now let's inspect how many missing counts are there under each column. So let's do this head of 10, because now we have converted that to pandas. Okay, so we get an error. So let's see, like column object is not available. Okay. Okay, so here I see an issue with is null. Okay, great. So that was the mistake. So the case, it's case sensitive, and we need to be careful with that. So here in the result, if you look at this, we have all columns listed under this because of the transpose we did. And then we have ID, where ID, because it's actually the primary key, so there is no missing count. And then we have name, where out of 1000 we have 138 missing values, and then age 22 out of 1000, and salary 9 out of 1000. So these are actually the missing count that we need to deal with later on in this video. So it's actually good to view this in a tabular format, but also let's view it in a using a visualization, which also helps. And how we do that will, okay, visualize missing data count per column. So for that, we will actually use this pyplot plt.figure. So let's define the fig size is equal to 6,4, and let's say bars equal to plt. We'll be using bar chart, and the x and y column, and then missing count is going to be the y. Okay, and then we will actually give it a title, missing values per column, and we will name the x-axis as columns actually. Okay, plt.y label count of missing values. Okay, and next thing, it's good to have a label on top of each bar to see. Label means the count, missing count. Okay, and in order to do that, let's use a for bar in bars height is equal to bar dot get height of plt.text. This is the one that we're going to use to bar dot. So we need to actually show that value in the middle of the x-axis, I mean like for each bar. So how we are going to do is get x plus bar dot get width of divided by 2. So this is actually x axis and then middle of the bar. Okay, and height is going to be the y. I forgot a comma. Y and top of bar, and then this is actually the text that we're going to show. Text label, and then it's going to be the horizontal alignment is going to be in center, and vertical alignment on top of bar and under as bottom. Okay, okay, so here we are, and it's a time to show that. Okay, get that plot. Okay, so here we are, and now we have a visualization rather than just a table. So when we have more columns, like for the real data, this is actually really helpful to show this missing counts, or like to see how many missing values we have using a bar chart when we have many columns. It'll be easier to, because visualizations are really helpful form than just a tabular form. Okay, so let's move on, and let's actually go to the first technique, which is drop. So either drop, so the thing that we can do is to drop missing data. So this is one way of handling with the missing data. So how we can do that, actually there are two ways to do that. So the first thing is drop rows with any null. So let's say for any row, if any of the column having null value, then the drop that column, whole column. Okay, So let's say df drop any is going to be df.na.drop how, so, okay, how is going to be any, and df.drop any.show of 5. Okay, so before running the cell, I'm gonna type the next way of doing it. So yeah, you know that like there can be two ways, right? One can be any and the other can be all. So when all column values of a row is null, or null, actually then drop that whole row instead of like just dropping row with any null. So how to do that? Drop rows with all null, df drop all, df.na.drop how equal to all. Okay, df drop all dot show. Okay, so let me run the cell and see how. Okay, so here for the first one, df drop any can actually, like you can see that we don't have any null values, and the size of the data set can get reduced a lot in this case, because if any of the column value is going to be null, then it's going to drop the whole row. And the next case is actually like drop rows with all null. So here you can see that we have this first row when the name value has null, because other column values are not null. So this is also another way of doing that. So this dropping rows technique, it depends on the situation. We need to choose whether we need to follow the drop any or drop all. Okay, so that was technique number 1, and the technique number 2 is fill. So this is very popular. You actually might have used a lot of this, fill missing data. So how we are going to do it? Fill missing with values. Okay, so we can do that using df.na.fill, and we actually specify for each column what kind of value we need to fill it with. I mean, when it's null. So for example, if there is a null value under age, then missing value under age column, then it's going to replace with 0. Likewise in salary. And let's say under name, if there is any missing value, then it will be replaced with unknown. Okay, so let's see df.fill show 5. Let's see how it will look now. Okay, so here we know that for the first row, name was null, and now it's getting replaced with unknown. And yes, likewise for the fourth row, also for the name. So likewise, because in the first 5 rows we don't have any age or salary missing, so we're not able to see. But like we have seen for name, for age and salary, when there is a missing value, it will get replaced with 0. Okay, so this is quite a familiar approach with fill na in pandas and na.fill in PySpark. We fill null values with some value that we specify. Okay, so let's move on to the next technique. Technique number 3 is fill with mean or median. This is actually usually done for numeric columns, because for other columns, mean or median doesn't make sense. So yeah. So how we are going to do it we actually gonna mean age, so we are gonna find out mean. So mean of df of age and using the collect function we actually collect 0 0. Okay, likewise for salary, mean salary. Okay, mean of TF salary dot collect 0 0. Okay, and let's say we will fill missing with column names, column means, okay. Df mean is going to be df.na.fill, and for age we will fill it with mean age. Likewise for salary we will fill it with mean salary. Okay, and let's show it. Okay, I don't think we had any missing values in top 10. So the next thing that we're going to do is we actually in real data set, we can actually use some visualization to visualize how the distribution has changed before and after filling with mean values. So how we can do that? So this I'm actually going to show you how you can apply it for a real data set. So how to do that? We'll actually have an original, because we need to compare with before and after. So df.toPandas, and this is going to be filled equal to df.dfmean.toPandas. Okay, for visualization we are actually converting to pandas data frame, and we'll define list of columns that we will actually check or fill with mean values. We have already filled with mean values that are age and salary. Okay, plot dot figure fig size is equal to 10,5. Okay, for I comma where in, let's say we'll enumerate variables. Okay, plot 1 2. Okay, so I've clicked on the tab for the suggestion. So enumerate variables comma 1. So we'll create plot for each of the variable. Okay, and because we need to compare before and after in one plot, so what we're going to do is we will actually combine before and after into one data frame. Okay, so data is going to be pd dot data frame. So okay, we'll have more than one values. So before filling is going to be original one, and after filling is going to be filled of where. Okay, Okay, so that's it. And data dot, okay, we'll use box plot because it, for the distribution, to show the distribution, it's box plot is actually the best case. So we will have a title because there are actually two, so we'll use distribution before versus after. Okay, and next thing is plot y label y. Okay, and we'll show it in a tight layout. Okay, so now let's just see how it looks like. Okay, so here we have two charts, two box plots for salary and age. And if you see, we have a distribution with values on the y-axis, and we are actually comparing before filling and after filling. So here, if you look at this, because it's only 1000 rows and we didn't have many or the missing values for each of these columns, so we're not able to see much difference in the mean. But so that also indicates that maybe the missing values were close to mean anyway. And so the key takeaway from this for this data set is that filling didn't distort the distribution. So that's actually one good thing. So for real data set, it can differ because there can be much more number of rows and many more missing values. But this is a box plot. It's a nice way to see how the distribution has changed, if there is a big change. So just to see like how that filling will affect the distribution. So yeah, I think this is actually this box plot using variables, like using the for loop, we can actually do it for all those columns, all those numeric columns which we filled with mean values. So yeah, I hope you understood this part, and let's then move on to the next part, or the next technique, or the last technique of the session, technique 4, which is conditional filling. For example, by group. So by grouping. So this is a technique that we can apply when we know that we can actually do the calculation. There is actually specific set of group which is recurring in that data set. So we're trying to find some mean or something for that group and then use it. So how we can do it, I can show you. So step 1 is, let's say we're going to mark rows where age is null. Okay, so df conditional is equal to okay. So this age was null is actually to see like when we after we do this whole filling, it's actually good to see like when whether the age was before null or not. So that's why I'm actually creating this df conditional. So df conditional age was null is when call of age, so when it's is null, then it's going to be 1, and otherwise 0. Okay, and then the step 2, compute. So we're going to compute mean age by a group. And let's say we are actually grouping it by name. So let's say that this is a client's data where we have this client's name under the name column, and the client can make recurring kind of like purchases or something. So we're actually trying to have, because the age of that same client is not going to differ, so we're actually trying to have that mean calculated for that name, and then we can actually fill if there is any missing value for that name. So what we're trying to do is we're actually grouping one value under name, or it can be anything else. It can be like some other column. But what we are trying to achieve is the data, or actually like that name or the rows, the name value is actually kind of a recurring, and if we calculate the mean age or mean salary, it's not going to create any distortion in the data. Okay, so maybe I can explain to you. So we have a client 1, and he has age for one row null, and let's say like he makes another purchase. So we have client 1 again, and here this time the data has this age filled right. So let's say 58. So what we are going to do is here, actually this null, because this client's one age is not going to differ, actually we need to replace this null with 58. So when we calculate the mean age by this client name, so then client 1 will get value 58, and it's going to replace this null value. So that's what we are going to do. So yeah. Okay, so how we are going to do it: average age is equal to df dot group by and name age So we will use this aggregate mean age, and then we will give it a name, average age. Okay, and the next step is join. So now we need to fill the missing data. So how we are going to do it: fill missing age with group mean, and so we are gonna have this df conditional, because we need to join on those values when it's on null or missing. So we will have join average age on name, and how we are going to do it, we'll have left join dot with column age filled. So we'll use coilies because they can be age and average age. So we'll fill only when there is no age, then we'll take the average age. Okay, so yes, I think that's it. And then df conditional is going to be, so let's say there can be some conditions when even after this joining we'll have some null values, because when the name itself is null. So let's say like in those cases, what we can do is we will actually use fill na, conditional dot fill na, and age filled is going to be 0. Okay. Now let's show this conditional dot show of 5. Okay. Sorry. On okay. So many typos. Okay, so here you can see that we have average age. So here actually, like here, we don't have any cases where age was null, because if you see the age filled or the end column with values having the same as age. So now I think it's better if we look at some cases when it was null and how it gets replaced. So in order to do that, I'm gonna add another step. Show only rows when age was null. So df conditional dot filter, call age was null 1. Okay, let's select. So now let's select all age, name age, and then average age, and the final column or the filled average age filled. Yes. Okay. Dot show. Okay, truncate equal to false. Yeah. Okay, another spelling mistake. Okay, so here we are, and here if you look at this data, we have cases. Scroll up. Okay, so here if you look at this age, so for this Frank, okay, let me just order it. Okay, use dot order by name. Okay, so here we are, we have, if you scroll this data, you'll be able to see that there were actually 2 entries, 2 rows for name Alice, where the age was null, but this average age that was calculated for this particular name from all the entries that we have in the CSV, it is actually being 36.90. So this null gets replaced with that value, okay, which seems good. And like I mentioned before, there are actually some cases where everything was null, name null, and age null, and even average age was null. So in this case, we use this fill na later to have it replaced with 0. And then there is this Bob with having actually 3 rows with null, whereas its average age calculated on group level was 40. So it will get replaced with 40 later. So likewise for all these names, you can actually see that there are actually like more entries like this. So this is what we have. Okay, so let me just. Okay, so here, even though it's showing we have an error because of this ordering. Okay, so now it's fine. Yeah. Okay, so the thing that I was talking about, null Alice, so it's the same. It just remains the same. The logic remains the same. So I think I don't have to explain it again. So yeah, that's it with handling missing values. We have seen some 4 different techniques which are widely used. Like one is dropping data, and then fill missing data, fill with mean, and the last one we saw was a conditional filling, example by group. So there are more techniques which can be used, like for example using imputer, which I haven't included here. But so these all cases, different cases, are actually like quite common and can be used on a real data set. So I hope you found this session useful, and let me know your feedback on comment section. And so let's meet in next video. Thank you.